Today's lesson is 1.6, Inverses of Functions Algebraically. Just a quick reminder, to find the inverse of a function, we are simply going to be switching or switch the x with the y. So we're going to be switching x and y. Let's go ahead and do example 1. We are going to find, and by find I mean write, the inverse of the function f of x equals 2x minus 5. Now I'm going to give you the 3 steps for you to do this, and they start with switching the x and the y, and then rewriting the equation. So the first thing I'm going to do is I'm going to take that f of x, and I'm going to write it as y equals, and then I'm going to just go ahead and copy the 2x minus 5. I'm going to take my x and my y, and I'm going to switch them. The y is going to become x, and the x is going to become y. So I would write it as x equals 2y minus 5. Now that I have them switched, I'm going to go ahead and solve for y. What I must do is I must get the letter y all by itself. I must leave it alone. So what I'm going to do is I'm going to come in here and I'm going to use my bright pink to help me do that. Now I'm just simply going to follow the rules of solving an equation. So to help me out, I might want to draw a line through the equal sign. And then I want to follow the steps for solving an equation. If there's any distributing to do, we've got to get rid of that first. Remember, distributing presents itself by showing parentheses, which I see none on either side of my equation. Then I'm going to look to combine like terms. Well, this side of the equation only has one term x, so there's nothing to combine. And this side over here, there are 2 terms, but because of that variable y, I can't subtract 2 minus 5. The next thing I would want to do is to get my variable on one side. Now, we're not solving for a variable. We're not solving to get a variable answer like x equals 2 or y equals 3. What we want it to say is y equals and then mx plus b, 3y plus 7, something like that. So I can't really do that step, so that step's out. And then I'm going to move into undoing the addition or subtraction. So right here, I want to undo this subtraction that I see by doing its opposite. The opposite of subtract is, of course, add, and I'm going to move it to the other side. I cannot add the x plus the 5 because they are not like terms, so I'm simply going to copy it. Instead of vertically, I'm going to copy it horizontally. I'm going to leave my 2y on the other side and come back and remind myself to get that letter y alone, that variable. The last step would be to get rid of the multiplication or division by doing its opposite. Remember, whenever you have a number with a letter behind it, the multiplication is hiding between it, and you're simply going to go ahead and divide by 2. What you do to one side, you have to do to the other. Now, this is a very common way of showing it, but remember, you are dividing each one, so you could separate it to say x divided by 2 plus 5 divided by 2 equals y. And you're perfectly done. Remember, whenever x is by itself like this, there is an invisible 1. So we could even write it as 1/2 x plus 5/2 equals y. This is just another form. We could also have left it just like it was right here. X plus 5 over 2 equals y. All of these are the same. This one, and this one, they're all the same. All right, the last step you want to do is to rewrite your equation now using function notation. So we have our equation, and we'll just pick one. I'll pick the one with the fraction because it is the hardest. Okay, and I'm just going to go ahead and I'm going to use the function notation. So I'm going to take this y and I'm going to change it to f of -1 of x because this is the inverse function of the original. It is not f of x, it is the inverse. So I'm going to change it to the inverse notation. All right, let's practice because that is pretty tough. Let's go ahead and find the inverse of these functions. So remember, step one, we're going to go and change it to y equals. I'm going to write the fraction like so. Okay. And then I'm going to go ahead and I'm going to switch. I'm going to make this become x, and I'm going to make this x become y. All right, so y, nope, see, even I can mess up. There we go, equals negative 5 over 2y. I need to get that variable y, that letter, completely by itself. Don't forget, your equal sign stays where it is. You're just kind of squishing everything towards it. All right, how can I get rid of that fraction? Well, there's a couple of different ways I could get rid of this fraction. Um, I can multiply by the denominator and make the fraction disappear into a whole number. I can think of this as a number that's just a fraction being multiplied by a variable y. And so to get rid of the multiply, I would divide by that fraction. Or I could think of, well, when I divide, I do copy, change, flip, KFC, keep, change, keep, flip, change, and I can do that as well. So it's totally up to you guys. I'm going to show the divide, and then I'm going to go ahead and show the KFC. So I'm going to show the division. Notice I'm dividing by the exact fraction that is there, the exact fraction that is there. If I'm going to do KFC, keep, flip, change, then I need to make sure that I put the 1 with the x, because that's what I'm going to keep. I'm going to keep the 1. I'm going to flip the fraction on the bottom, and I'm going to change the multiply or the divide to multiply. So I'm going to do this, which is going to give me negative 2 over 5. So I end up with negative 2 over 5x is equal to y. Remember, the last thing you want to do is change this y to your function notation, which is the f of negative 1 of x. So you would write f negative 1 of x equals negative 2/5 x. There's our inverse. Let's try another one. Okay, so change the f of x to y and change the letter x to the letter y. Go ahead and switch them. Make this one x, make this one y. No, I have two y's. What's going on? Hold on. There we go. Make this one y. All right, so I have x equals negative 1 plus 1/5 x. No, y. There we go. It's very tricky, ladies and gentlemen. You have to take your time. There we go. I want to get the letter y by itself. I want to get that variable alone. Let's go ahead and draw our line through our equals to help us with the movement of stuff. All right, so there should be no distributing to take care of. There should be no like terms to combine. Your first thing that you should do is move your addition or subtraction. Be careful. This one looks like it's add, but we're adding a negative. And so the negative, to make it become 0, I have to add it. Negative 1 plus positive 1 cancels out. Negative 1 minus 1 is negative 2. I'm never going to be able to add when I move. I'm only going to be able to switch the presentation of it from vertical to horizontal. I'm going to keep my equal sign right on that line, and I'm going to keep my fraction and the variable y. Okay, so remember, here I can show you another way to get rid, or we can just go ahead and do the same thing we did. But I think it might be easier for you, maybe, I don't know, to see multiplying by the reciprocal, okay? Here's another way that you could get rid of it. Multiply by the reciprocal, crosses it out, leaves me with y. I'm going to do that over here as well. Multiply by the reciprocal. Now notice the reciprocal is 5 over 1. 5 over 1 is the same as just 5. So what I'm going to do is I'm going to take this 5 and I'm going to distribute it inside. So I have 5x plus 5. That wasn't as scary as I thought it was going to be. Now I just have to go ahead and take my y and change it to my inverse notation, which is this guy right here. And I'm going to say f of negative 1 of x is equal to 5x plus 5. There we go. All right. We could use the composition of functions to verify if two functions are inverses of one another. My composition formulas look like this. F of g of x. This is more commonly used than this part right here, but you can see either one. Notice that this circle right here is open and it kind of looks like the word fog, but it's simply what it means is that we're going to substitute g of x, the one that's inside the parentheses, the one that's inside the parentheses, the one that's second, into every x of f of x. Okay, that's one way you can do it. Or you can choose to flip them and do them the other way. Notice this one just has g and f flipped. That's all it does. And so this one means we're going to substitute f of x into every g of x. If either one of them, this one or that one, equals x, I'm going to go ahead and highlight that for you guys. It has to equal x. Then they are inverses of each other. Okay? If you get x when you do the substitution of one function into the other, they are inverses of each other. You only need to do one composition. You do not need to do both. Okay, don't think this is, oh gosh, this is going to be a lot of work. I have to do both. No, no, no. You only have to do one of the compositions. So sometimes one looks easier than the other. It's fractions, it's division, it's stuff like that. And it's really just your call. What do you think is an easier substitution? Let's go ahead and take a look at one of them. Determine if the following functions are inverses of each other. Here is my f of x. Pretty scary looking. It has a division, kind of a fraction, if you would. That's kind of scary. And then g of x is simply just 3x minus 1. It is my call. I'm going to decide how I want to substitute, okay? It's totally my call. And I'm thinking if I substitute g of x into f of x, that's going to be easier, okay? So what I'm going to do is I'm going to do f of g of x. And what I'm going to basically do is I'm going to take this right here, all of this, and I'm going to put it right here in for x. That's what this means. I'm going to take that purple x and I'm going to replace it with the parentheses, what's inside the purple parentheses. So I'm going to go ahead and say 3x minus 1 plus 1 over 3. Okay, notice I could even put my purple parentheses if I want to. And there you go. I've gone ahead and done my substitution. One into the other. Every x I see in the original goes the other function. Now I'm going to go ahead and simplify. Okay, so I can maybe the first thing I do is I drop the parentheses. Okay, Then I'm going to combine like terms in the numerator. So I'm going to look at the numerator and I'm going to say, well, -1 plus +1 are like terms. I can add them together and I know that they are 0, so they would cancel out, leaving me with 3x divided by 3. I'm going to keep simplifying, right? I know what 3 divided by 3 is. It cancels and it's 1. I simply have x. Once I cannot simplify anymore, I am done. So here is my simplification. Oops, I didn't see my bracket. There we go. And now I'm going to make my conclusion. Are they inverses? I'm going to say yes or no. F of g of x is equal to x. That's what I just showed. So I'm going to say yes, f of x and g of x are inverses. Okay, if I had gotten x plus 2, no. 1/3 x, no. Okay, all right. Oop, let me see. The last thing that I want to talk about is the horizontal line test. What the horizontal line test, and remember this is what a horizontal line looks like, intersects the graph of a function at, hold on, at more than one point, then the graph is not considered to be one-to-one, which means it does not have an inverse. Okay, if a horizontal line intersects a graph more than once, it is not considered to be one-to-one, and thus it is not an inverse. So take a look at our two graphs right here. We have a linear function in the black line. And if we do our horizontal line test, it touches it once. This one has an inverse. Notice our quadratic. Our quadratic has been flipped and moved. But notice when I do the horizontal line test, 2 points of intersection, this does not have an inverse, does not have an inverse. All right, let's determine if these two functions happen to have inverses. So here's our first one. F of x equals 1/5 x plus 1. Remember, you can always do your, let me grab my blue here. You can always do y equals mx plus b, and where m is your slope, 1/5, and b is your y-intercept, 1. Remember, your slope is going to say 1 up and 5 to the right. So here we go. We're going to begin at 1. We're going to go 1 up and 1, 2, 3, 4, 5 to the right. 1 up, 1, 2, 3, 4, 5 to the right. Remember, we can also go and switch that. Go 1 down and 5 to the left. 1 down and 5 to the left. 1 down and 5 to the left. Connect them together. I'm going to do the best I can. There we go. There it is. Let's do our horizontal line test. Now imagine moving that line through there, but anywhere I move it, it's going to only intersect it once. This one has an inverse. I don't know what it is, but I know it has an inverse function. All right, let's take a look at the second one. And oh, it's missing something. Here we go. It should have a square right there. Oops. There we go. It should have a square right here, x squared minus 2. Now remember, x squared minus 2, the minus 2 is going to move my vertex from the parent at 0 down 2, and then it's just going to look something like this. It doesn't have to be perfect. Oops, no, it's not perfect at all. Let me see. It's going to look something like that. There we go. If I draw the horizontal line through, notice it's going to touch 2 times. This one does not have an inverse function.